Welcome back to Algebra 2. Welcome to the last lesson of Unit 1. Hard to believe, we're already at the end of Unit 1, which is characteristics of functions. The graphs of functions have many key features whose terminology we will be using all year. It is important to master this terminology, most of which you've learned in Common Core Algebra 1. So, exercise 1. The function y equals f of x. So they're saying that there's a relation that's a function, is shown in the graph at the right. Answer the following questions based on this graph. So state the y-intercept of this function. So the y-intercept sits right here, and that is the point. The y-intercept, by the way, I always put down, it's when x is 0. So our y-intercept would be a point that is 0, comma, 2 at this point. All right, but the y-intercept, they're really just asking, the answer would be 2. The point that's associated with it is 0, comma 2, but the answer is 2. State the x-intercepts of the function. So what is an alternative name that we give the x-intercepts? Well, if you remember back in Algebra 1, we called these x-intercepts also zeros. Sometimes we called them roots. And they come into play very often with quadratic and other big functions. So the roots are where it crosses the x-axis. So where it crosses the x-axis is here and here. And again, the points here, the x-intercepts are going to be when y is equal to 0. But here again, they're just looking for the x-intercepts, not the points. So 1, 2, 3, 4, 5, 6. So my answers are -6 and 1, 2, 3, 4. You can either leave them with nothing around them. You can put them into set notation, all right, which is the squiggles, but you never put them in parentheses because that always is point notation. Okay, so but it's okay to leave them like this. All right, so over the interval. So what does the word interval mean? We've talked about it a couple of times. Interval, again, let's go on with our translating. These are our x values. So over the interval, so this is telling me right here, between -1 and 2, is f of x increasing or decreasing? So between -1 and +2, I think it's pretty easy to see that it's increasing, right? Because our graph is going from here up to here. So, and it says, how can you tell? So we're going to say over the interval, -1 less than x less than 2, the graph, or you could say f of x, the graph is increasing. And it says, how can you tell? So I'm going to write because it is heading in an upward direction. All right, that makes sense, right? Again, when it asks you questions like that, don't think that they're always asking you crazy mathematical questions. Sometimes they're asking you just to explain what you're talking about, just like you'd explain it to your grandmother. Okay, so we know it's increasing because it's heading upward. If it was decreasing, it would be heading downward. So D says, give the interval in which f of x is greater than 0. Again, let's go back to our translating. F of x is the same thing as y. So y is greater than 0. And when y is greater than 0, it's like saying y is positive. So where is y positive? Going up to our graph here, y equals 0 is positive. right from this point upward. So now, when it's asking where it's positive, you're just going to use either interval notation or set builder notation. So we're going to come up with our points at which it's positive. So at this point, it's negative. We're not including that. So we are 1, 2, 3, 4, 5, 6. So this is negative 6. This is 1, 2, 3, 4. This is positive 4. Now, you can't say it's actually positive. It's actually greater than 0 at negative 6. So we're not going to include negative 6, nor are we going to include positive 4. So even though that looks like a point, in this case it's interval notation. Another way you could say it is negative 6 is less than x, which is less than 4. Okay, because again, they're talking about intervals here. These are our x values. Take a minute, think about that for a minute, and just kind of review what we just talked about on the graph. E says state all the x coordinates of the relative maximums and relative minimums, which are the peaks and the valleys. So they're not asking us for the maximum, the absolute maximum. They're asking for the relative maximum and minimums, which means that if you take a look here, let me just bring this down a little bit. Our absolute minimum is right down here at 1, 2, 3, 4, at negative 4. All right, our absolute minimum is up here at 1, 2, 3, 4, 5, 6, 7, 8. What they're asking for are the relative maximum minimums, which means what they're looking for is this point here and this point here. All right, so it's a valley and it's a little hill going on there. So what did we say this is going to be? 1, 2, 3, 4, 5, 6, and this is going to be negative 2. And it's telling us it wants the x coordinates though. So I just gave you the y coordinates. So let's go back 1, 2, 3, 4. So this is negative 4. And this one's going to be 1, 2, 3, 4, 5. This one down here is going to be x is 5. So, and it says to label them. So let's label it. So this is going to be a relative maximum. And this is going to be a relative minimum. So what are the x values we said? 6 and negative 2. Nope, negative 4 and 5. X values again. X coordinates. So negative 4 is our relative max. And positive 5 is our relative min. Kind of an odd question, I have to tell you. I think I'll delete it next year. Okay, so let's move on. Let's take a look at exercise 2, and then we're done. So this is a quick lesson. So consider the function g of x equals the absolute value function shown here, defined over this domain. So defined over that domain means we're going to have a domain restriction between negative 4, 1, 2, 3, 4, between here and 1, 2, 3, 4, 5, 6, 7, and here. All right, which means we're not going to put arrows on this. This is where it's going to start and end. So it says sketch the graph of the function. So again, we're going to take a minute and we're going to pull up our calculator. Okay, so this is what it would look like on our calculator. Notice when I pulled up my table, I made sure I got that turning point, which is right in the middle there, which is right here. So our points are between negative 4, which I don't have here. I have to get the negative 4. Let's do the ones we have. 3, negative 4. 1, 2, 3, 1, 2, 3, 4. And 4, negative 2. And 5, 0. All right. So the rest of this, as we pull this up into our calculator, looks like this. Here, And let me just slide this down a little bit. And here, that's our vertex right there. And then it comes back up. So that was not my vertex that I pointed to. That's not. I was thinking this was -2, which is not. So this is not the vertex. But in our calculator, we would be able to come up with these pretty easily. All right. So this is basically what this graph looks like. Whoops, one more here, going down to here. And so that's what it looks like. No arrows. It tells us to stop at these points. And technically, you shouldn't have these points in, these yellow ones. That's helpful, but erase them when you're done. So that's what our function g of x looks like. So this is g of x. So that's easy enough. We use our calculator, we get our points, and we plot them. And we know it's an absolute value, so it looks like a v. So we're in good shape. So now let's see what it says to do next. State the zeros of the function on this interval. So in other words, between the -4 and the +7, where are the zeros? So we know that the zeros are the x-intercepts. And that's going to be here at -3 and here at 5. And then it says state the interval over which g of x is less than or equal to 0. We're going to translate. That means that y is less than or equal to 0. And when y is less than or equal to 0, it's telling me that y is negative. So again, y is negative anywhere below the x-axis. So how are we going to write this? Again, we're going to use those zeros that we just used here, but we're going to say it's between the interval of -3 and +5. All right, looks like a point, but we have to remember that what it means is that -3 is less than x, which is less than 5. Again, the interval means x values. Okay? Because I know it's negative from this point down. Hope that makes sense to you. So this is the piece that we're looking at that's less than 0, which where all the y's are negative. Going on to E. E says evaluate g of 0 by using algebraic definition of the function. What point does this correspond to on the graph? So what we're saying is x is equal to 0, and we know when x is equal to 0, so when x is equal to 0, we are looking for the y-intercept. So using our g of 0 is equal to 2 parentheses, 2 absolute, 0 minus 1 minus 8. All right, so this becomes 2 absolute value -1 minus 8. The absolute value of -1 is +1 minus 8, and 2 minus 8 is equal to -6. And -6 is our y-intercept. Are there any relative maximum or minimums on the graph? If so, which and what are their coordinates? So there really are no relative maximum and minimums. There's really an absolute minimum, and that's this point right down here. This is my absolute minimum. So if I'm not sure how to answer that question, we can always say, so what is this point? This is the point 1, 1, 2, 3, 4, 5, 6, 7, 8. This is the point 1, -8. So let's see if we can come up with a way that we can say this here. So it's asking what are their coordinates. I would say there are no relative maximums or minimums but there is an absolute minimum at the point, now I forgot what it was, a -8. I think that's a great way to answer this question. You're actually giving them more information than they want, but it's right information, so you're okay. So that's the end of this lesson. So we're down to 16 minutes, which was pretty good. Okay, so like I said, at this point, if you want to take a look at some of the independent practice, feel free to get started on it. Otherwise, we will get through it in class. But like I tell you all the time, sometimes class, we can't get through all of it. So maybe if you just took 5 or 10 minutes and tried to apply some of this, it might be helpful to you. All right, so until next time, always make good choices, okay? Because remember, like I have in the classroom, the sum of all your choices equals your life. Have a good day.